Welcome to Lesson 9.6, Interpreting Graphs. So today we're going to talk about those graphs that don't necessarily give you any quantitative values. They just give you a picture of something that happened. So for example, in this one we have a person's trip to the supermarket. On your y-axis you have the distance the person is from home, so 0 being home. And then on the x-axis you have the time. So if you take a look at this graph, you can see that they started at home and then they fairly quickly started to get further and further away from home as they were riding their bike. Now, this doesn't go up so fast because they weren't driving a car. If they were driving a car, they would be going a further distance in a shorter amount of time. But because this person was riding their bike, it's a shorter distance in that same amount of time. Now, once they get to the supermarket, they can't get any further away from home because they're just staying at the supermarket. So the time keeps going, however, the distance does not. Now the person is done at the supermarket and they're coming home, and they're probably going a little bit slower because now instead of just having themselves on the bike like they did on the way to the grocery store, now they have all these groceries that they have to bring home. So they're getting closer to home, but it's taking a longer amount of time. So their rate of speed here was quicker than their rate of speed here. Okay, and of course, as they are traveling, the time is going on, and the distance is changing. Now, the reason we don't continue up the graph is because since we're going home, we're not getting further away from home. Okay, so the distance from home, we're getting closer to home. So we actually have to get back to 0, which is home. Right, if you take a look at the next one, you live 6 blocks from the school. The graph at the right shows your walk home on a sunny day. Describe what the graph shows. So what we need to look at here is that on our y-axis, it tells us this is the distance. Okay, so going up is the distance. And across the x-axis is time. So if we look at this first chunk right here, we're walking a steady pace on our sunny day walk. Okay, so we started with a brisk walk. Okay, because we're going to say that we went pretty quick considering the fact that we went 2 blocks in only 4 minutes. So we started with a brisk walk for the first 2 blocks. Now, because our distance didn't change, we stayed in the same spot, so we must have stayed at a park or stopped at the library, something to that effect. But because it says your walk home on a sunny day, I would say that we stopped and ran into a friend. So we can say we stopped and talked with a friend and we can look here, we know it's 4. We started here with 4, so each of these increments is 4 minutes. We didn't stop and talk for 16 minutes. We actually stopped and talked for 4, 8, 12 minutes. Because it takes us 12 to get from 4 to 16. We stopped and talked with a friend for 12 minutes. Then we began a slower pace home and we can say 4, 8, 12, 16 minutes. But then it started to rain, and we can make that assumption because if you look, now all of a sudden our rate of speed goes very fast. It skyrockets. And that tells us that no longer are we walking slowly. Now we're starting to pick up that pace again. So either they got really excited to get home or it started raining. I would say it started raining. There's really no right or wrong answer here as long as you follow the detail of the graph. If you told me that you slowly walked for this first part, that would be incorrect, as you can see that you went 2 blocks in only 4 minutes. That's a fairly quick pace. So that would be considered incorrect. But if instead of saying a brisk walk, you said they jogged for the first 2 blocks, that would be acceptable. Okay, so then we began a slower pace home for 16 minutes, but then it started to rain, so we picked up the pace until we got home. Now, with the grocery store example, we talked about how we had to get back down to 0 to get to the home. So if you look here, this was home, and then we went away from home, and then we came back home. In this case, we were never home. We started away from home and we were working our way towards home. So what this tells you is we started 6 blocks away from our home, because when the graph ends, we end at 6 blocks. Okay, so here's a situation, and I want you to try this on your own. Try to sketch the graph, and when you come back, we'll check your answer. But Sierra's mother drove her part of the way to school. Sierra waited for a friend and walked the rest of the way to school. She took a bus home. Sketch a graph to show the distance Sierra traveled compared to the time. So again, you want to put distance on one side and time on the other. A couple of things that are important to note here. Sierra's mother drove her part of the way. Driving is going to be a faster pace than walking the rest of the way. Then she took a bus home. So you want to keep all these things in mind when you're drawing your graph. So you can take a minute, pause, draw your graph, and when you come back, we'll go over it. Alright, so since Sierra's mom drove her part of the way to school, that distance traveled over time is going to be fairly quick. Okay, her rate of speed is going to be faster because she is in a car. Since we don't have a specific amount of time or a specific distance traveled, we have to do our best to show that this is a fast rate. In order to do that, you want to draw a steeper line. Okay. Then, Sierra waited for a friend. We forgot to highlight that part, that she waited for a friend. As she waited for her friend, she went nowhere, but time still went on. So we have a flat line here. Now she's walking to school. Okay, so this shows a slower pace than when she was in the car, because, well, if you can walk as fast as a car goes, you are pretty quick. So we have a slower pace, which means we have not as steep of an incline here. And then we also have to include the time she was at school. You can't just skip the time she was at school. Okay, so we can't just all of a sudden go from here to, taking the bus home. We have to account for all the time she spent at school. And she'd spend more time at school than she spent waiting for her friend and walking to school. Think about it. You spend about 8 hours a day at school, and it only takes you about 20 minutes at most to get to school. So this waiting period at school should be much longer than your traveling time. Now, since she took the bus home, we need to be getting closer to home. Okay, so you could say that the bus trip took her back this way. I would have drawn it back this way because now she's going back home. This graph shows her just over time. Okay, because it's the distance traveled compared to time, the graph went back up this way. Not a problem. It's also not a problem if you did the same type of incline and then made it back to home, like we did in the grocery store. Okay, for your posts on Edmodo, you need to match the graph to the situation. Alright, so you have graph A, B, and C, and you have situations 1, 2, and 3. So on Edmodo, when you post, you can post 1, B, 2C. Whatever graph matches the number, you can just post that number and that letter together. Only do one post, please, so it's easier for us to go through tomorrow. Again, if you have any questions, make sure that you write them down or post them on Edmodo so we can go over them in class.